Hello, my name is Mark, and first off, I want to say thank you for the opportunity. I'll walk through my thought process of analyzing a financial growth trend um, process as clearly as I code, so you can see my design decision. So, given an array of yearly revenue growth percentages, I know that the array is already sorted in non-decreasing order, and I know that values may include negatives. So I'm thinking that we must square each value and return the squared values sorted in non-decreasing order. So I've got um, VS Code opened up, and I opened a folder called Analyzing Financial Growth Trends, and I have two files, which is analyze financial growth trends.py and test analyze growth trends.py. So let's talk about our example for what our data would come in as. So you know that it'll be um, in an array. Oh, what is that? Oop, I know that. Um, Sorry, let's clean this up. Sorry about that. And then so we'll create an array. We'll have an input of so to be input, and our array would be like -5, -2, 0, 3, and a 10. And as for our output, um, this would actually be when we square it, it'll be 0, 4, because negatives will turn positives, 9, 25, and 100. So this would be data of the input and the output of how it would look. So knowing that, I would have to, I'd like to clarify a few assumptions before we start. Um, First off would be, is the input always going to be sorted? For that, I think that was stated in our objective that it was. So we'll say it yes. And then can the input be empty? I'm not sure it could be with data, so we would have to handle that. Can it contain one element? Um, Given that perception, I would think that yes, it would be safe to say one element could be part of it. Can it contain all negative numbers? I'm sure financial data can come in as all negatives. So we do have to figure that out. And then, do we modify the original array or return a new one? Um, given given that, I think we would say we would return a new array because yeah, it'll just be cleaner. So our assumption would be yes, it is sorted, and it can be empty, and it can contain negative numbers, and we will return a new array. I'll start with a simple approach being before optimizing. So our approach would be to probably square each element, um, sort it, and then sort the result, and then return it. So with that in mind, we can um, we can create our function. We define it with saying analyze growth, analyze growth trends. Then we would have to grab the growth percentages, and then we would have to square it. So we'll say squared would equal um, percentages, and then we'd have to return it. We have to return sorted. We have to return the sorted squares squared. So that's what we do. So for that, we this will give us our squaring complexity would be O of n. Our sorting would be O(n) log of n because of the squared, and then we're trying to sort it using the sort method. And then our space complexity would be O of n. Um, I would mention this. I would have to mention that I probably can produce a correct baseline solution. So before jumping to the optimization, I want to briefly discuss other ways this could be handled. So for option A, we can say insert. We can use an insert into a sorted list one by one, which we could square each number and then insert it into a new list at a correct position. But the insertion into a sorted list is O of n, and then doing that how many times? N times becomes O(n) squared. So that's like not, that's probably the worst way to do it. And then option B would be to use a built-in sorting, which we just did, which is more clean, readable, um, but it's easy, but it's O(n) log n. This is acceptable, but for when what we can observe by this is the input is already sorted. So that means the largest absolute values are at the ends, and then the largest squares must come from either the leftmost or the rightmost of the elements. So instead of sorting again, we can probably restructure this to achieve a ON time. That leads me to maybe we can optimize this solution. And I think optimizing optimizing this using a two-pointer solution, looking at both ends of the array, and then pulling it out or sorting it from there would make our will implement a more linear time solution. So let's see if we can do that. So since we created our this function here using the squared, we can just um so wouldn't need this. We wouldn't need the we would need the square, but it would be later on. Let's implement let's implement the pointers. So okay, so we'll we'll need the length. We need the length of the growth percentages. So let's put this. Let's get our length for growth percentages. So we see length um growth percentages, but we need to save it. So we need to save it, and then we'll just put it in a variable n, and then we need to get the results of that. So let's let's do result equals um the array times the whoops times n, and then our left, we have to create the left and right pointers would equal 0 and minus 1. So we're grabbing we're using our pointers to point at the array. We're checking if always, we're grabbing the left and right and comparing it to each other. And then the positives, we will save that by doing saving it in a n minus 1, and would save and we'll call it pause. So while that's happening, we can create a loop for the left, and we say while left is less than or equal to the right, and and if if the absolute value growth percentages, let's call this growth percentages, um the left. So this is the left side greater than the absolute value of of growth percentages of the right. Now we'll get the result of positive and then growth percentages of the left side. And then we'll put that in account. I'm sorry, hold up, absolute value okay. Yeah, we'll say we'll put we'll we will create variables left right equals 0 and -1, and then keep a tab on that. Let's say n minus 1, and then we'll put in we'll save it and positive, and then if we have to say else, if else the result of our positive was from growth, um, growth percentages of the left, uh, squared, squared, and then we'll say left, keeps tabs on that, plus equals incremented by 1, or minus equals. So we'll decrease by 1, the positive, and then we'll return return result. It's okay. Um, oops. Close that off. Um, so return result. So here we have n equals the length of the growth percentage. That means we store the length so we don't repeatedly calculate it. And then the result is 0 times, wait. 0 times result. Wait, what happened here? Something got messed up. Oh, that's what happened. So the result of all we prelocate space. So we created our space. This ensures the O of n space and avoids resizing. And then we initialized our left and right pointers. And then we start filling from the end. So I mean from the back, because the largest squares would go over there first. They're saying so we're saying while we continue until both pointers cross, meaning all elements are processed. So we continue until both pointers cross each other. Then it stops. And then we compare the values. We compare absolute values because squaring removes the signs. So we gotta account for that. And then on this side we say left. Um, um, for the left case. So this is for the left case and this is for the right case. We say we're just doing we place the largest square at the current positions, comparing the left and then and the right. And then from there we move a position back by saying um positive right here, positive minus equals 1, and then we return the result right here. So that would be that would be our algorithm for our analyze growth trends. So let's see. Let's I need a pause first and take a water break. Mm. Okay, I'm back. So now that we've created our program, we can create our test to see if it runs. So for this, like we used Python, so we would have to import unit test from Python, and then we'll say from analyze financial growth, import analyze growth trends. So we need to create our class for our test. Uh, let's move that down. So we'll call it test analyze oh, that wait, yep, test analyze um growth trends. So we would need unit test dot test case. Make sure we put those. So so we would use our test analyze growth trends, and then we'll put our argument parameters of unit test dot test case. So let's create our first test. So we have to define a function. Let's call it a test. Test basic. Let's be more specific. Positive numbers. Then it would need self. It would need self. And then in self, it would have to say self dot assert. Assert. Way down there. Assert equal. And then inside that, we would have analyze growth trends, create our argument array, and then this is positive numbers, so we'll fill it with positive numbers, and then we'll fill these with the squared values. Okay, let's see if we can run this. Python dash m unit test. Say test analyze growth trend. Is it? Sorry, this thing is blocking my view. Test analyze growth trends. Oh, yes. It failed. Okay. Assertion. List diff what? One. Oh, okay. Hold up. Let's see what we did here. One test basic positive number. Yeah, that's correct. 14916. Uh-oh. Analyze growth trends. It did. One, two, three, four. Dude. Yeah, it should be correct. Two, three, four. First differing element is zero. Hmm. Hold on. Let me uh let me let me dive deeper into this before we continue. Why did this not? On this again. Hope this. Let's control S. No test ran. Hmm. Shit. No. Okay, so I figured out a bug. I switched I was returning the array and it wasn't assorted correctly, so I had to switch my return uh the way I grabbed it up here and then I turned it around. So now it's the test runs good now. We'll run it one more time and then we run test is good for our test analyze. Oh, let me check. Yeah, right here. Sorry, I was pointing at this. Yeah, our test analyze is good now. It returns in the correct order that it should. Okay, so now that we did test one for our basic, um, let's grab this, Control C, and we'll do it one more time, and then so now we got one, two, something didn't turn out good. So we got three. So now that we got three of those, we can start creating our other tests. So we'll create another one saying we'll test for probably let's close this off. Let's do a test for oops. Um do test for including zeros. Including zero. So we'll call that test for including zero. And then self is correct. Self dot self dot assert equal is good. Analyze growth trends is correct. And then let's just let's insert a zero here. And then let's insert a zero right here. And see how that runs. Oh, let me code block this off. And oops, do that. Save that. It's running one more time. Okay, so we ran one test and then we ran another test. So they both came back good. So now that we've got that, let's test for something else. We can probably test for oh, let's do a negative number. So we'll say negative number and then we'll put let's put some negative numbers up in here. Oh, there's a negative. 3, -2, -1. Down below we'll have just run this like this, save this. Okay, that'll be our negative numbers. Give me 1 second. I'll be back. This one is running one. So, looking back at my test, um, I seen that I actually was running only one test earlier. I thought they were running one at a time, one after the other, but it wasn't so. It was actually just running the first one and then it skipped these two. So when I was looking at it, I actually added the class here. This was here and right down here. So I just deleted it because yeah, you just call it once up here. You create the class right up here and then you just put your define your test cases below. Oh yeah. So that's my other troubleshoot that I've done. So okay, there it says 3 tests. I thought this one was running like one at a time earlier, but it was just running once. So, okay, so now that we have the three normal cases, we can create an edge case. So we'll just use one of those without the class, without the class. So make sure, yeah, that doesn't happen again. So for our edge case, we'd have to think about what can we encounter. So dealing with an array, we would probably have to deal with what we mentioned earlier with empty, dealing with a empty list. So let's call this empty list, test empty list, and then yeah, we'll just give it an empty list. an array, empty array list. So we'll do that. We'll save it and we'll run this and see how it turns out. Okay, so it ran good. So we handled that it can handle an empty list without errors. As you can see, it ran 4 and it was okay. So now that we got that, we can try and recreate another one. Um, Control V that one. And then since we did an empty list, we can try for probably um, a single number. Um, Single number list. What single number? Let's rename this single or value. So you can just call it a value or number. Let's call it a single number. Okay, let's save that. We'll run this again. All right, so we ran 5 tests and everything's okay. So we ran just a single number in an array and turned out good. Nothing broke. Okay, now that we we did an empty one and we did a single value, single number. Let's uh let's try some let's do some mixed values. So we can make this a positive. Let's make that a positive number. This one we can make it as a 0. Let's do that. Then that'll be a 109. Oh, let's 0. That's a 1. That's a 9. Okay, save that. Go down there. Let's run this. Um, is that 5? Wait, 1, 2, 3. Lost 1, 2, 3, 4, 5. Should be 6. Oh, yeah. 1, 2, 3, 4, 5, 6. Am I losing it? Wait. Oh, because it ran the same. I forgot to rename it. So since let's call it mixed numbers. Test mixed numbers. Mixed. Let's try that. Try that one more time. Yeah, so I forgot to rename it, so that's why there was just 5. Okay, so we got 6 tests. Everything's good. We tested mixed numbers. Uh, we did our normal cases. We tested for our basic positive numbers. We tested for including a zero in our array. We tested basic negative numbers, all negatives. And then for edge cases, we tested for an empty list. We tested a single number. We tested mixed numbers with negative, zero value, and a positive value. And all tests ran in 0.001 seconds, which is optimized for our time and space complexity, O(n), which we narrow down versus the other way using the squaring it and sorting it, which became O(n) and then O(n) of log of n. So, um, in summary, we create a program that was efficient, scalable, able to handle uh, an infinite, I wouldn't say infinite, but of course a definite, a big amount of data, and optimize for with delivery of O of n. And then we create our test case with show that it can handle the different issues, and then with positive results. Okay, this concludes my interview. Thank you. Mm.